In this lesson, we want to be able to say that I can solve systems of linear equations. Before we actually go and solve any systems of equations, we want to be able to understand what they are. So whenever we say a system of linear equations, we are talking about two equations or more. We could have more than two equations. Let's say we have, for instance, y equals to 2x plus 1. That's not a system of equation because that's only one equation. Now, if we take another equation and are wanting to compare the two equations, so for instance, y equals to, let's say, 1 over 2x plus 5, now we have ourselves a system because we have two equations that we are trying to compare to see if they have anything in common. So another word that we have is the word consistent. A system of equation is consistent if we have at least one solution. So at least one solution. It is inconsistent if it has no solution. By the way, that symbol means no solution. I'm just doing that for quick notation. If it has no solution. It is independent if it has just one solution, so exactly one. So one solution. And it is dependent if it has more than one solution. By the way, we can intermix some of these. It can be consistent and independent, meaning it has exactly one solution. It can be consistent and yet dependent because it could have more than one solution. However, if it's inconsistent in none of the others because that means it has no solution. Just to give you guys a visualization, a representation of this, we could have, let's say we have this equation right here, this line. And let's say we have this other line that goes this way. This one would be consistent and also independent because it has exactly one solution. Let me give you another example. Let's say we had this, where this was one of the lines and this is another line. Those are parallel lines. Do parallel lines ever cross? No. So that would be an example of inconsistent. If it does not have any solutions, if they are parallel. Another example, let's leave this green line on here. For it to be consistent and dependent, they must be the same line. So if we have the red line over the green line, that is consistent yet dependent because they are the same exact line. So that's a little bit of vocabulary. Let's go ahead and actually graph a few and solve a few systems of equations. So we have this system right here. We have y is equal to 2x plus 5, and we have x plus 2y equals to 0. So let's go ahead and just graph these equations out and see if we can find a solution. By the way, we're going to do three different methods. We're going to do a graphing method, we're going to do a substitution method, and we're going to do elimination method. We're only going to get through graphing today and also a little bit of substitution. In another video, we will work on finishing up substitution and elimination. So the first one, y is equal to 2x plus 5. That is in slope-intercept form. So we know the y-intercept is at 5. And we know that the slope is 2, so 2 over 1. So we rise by 2 over by 1. We rise by 2, we go over by 1. We can also rise by negative 2 and run by negative 1. So let's go ahead and just graph that out. Make sure that whenever you're answering homework questions, you are putting arrows on both ends of this line, meaning it goes on forever in either direction. So that's one of the equations as written down as a graph. The other one that we are going to have is going to be, it's not in our slope-intersect format. We can make it go into slope-intersect format if you really wanted to. We could also just choose 2 points. We can do it that way. I'm going to go ahead and solve this one for slope-intersect form, though. So I'm going to minus by the x. So we have 2y is equal to negative x plus 0. Divide by 2. So y is equal to negative 1 over 2x plus 0. So our y-intercept is at 0. And our slope is negative 1 over 2. So this means we can rise by negative 1, run by positive 2. Rise by negative 1, run by positive 2. Or we can rise by positive 1, run by negative 2. Whenever we are solving a system of equation, we want to find where they cross. This one has exactly one solution, and they cross exactly at negative 2, comma 1. That is the solution by graphing this system of equations. So graphing system of equations, you just graph them out, graph the 2 lines, and figure out where they meet, where they cross. Whenever you're doing this, you want to make sure that you are accurate on where your points are. Otherwise, your answer may be a little bit off. Let's do another example. Solve by graphing. The first one is nice because it is already in slope-intersect form. So we have intercept being at 2. Slope is 1 over 2. So we rise by 1, run by 2, rise by 1, run by 2. It's very similar to the other method that we had over there, the other equation. So we have this line that we are going to graph right there. The other one, that is an ugly equation. What I'm going to do with this other equation that's in the system is I'm going to go ahead and solve it for the value of y. So let's go ahead and just distribute. Remember, whenever you're solving equations, we want to simplify both sides. So we distribute, so this would be 6x minus by 10y equals to x minus by 20. Let's solve out for y. So let's get those x's together. Let's move the 6x to the other side. So minus by 6x, minus by 6x. So we have negative 10y equals to negative 5x minus 20. Divide by negative 10. So this would be y is equal to, okay, negative 5 divided by negative 10 is a positive 1 over 2. And this would be x. And negative 20 divided by negative 10 is plus 2. Wait, that is the same equation as the other one. So these are the same exact line. The red would go over the pink. It's the same line. So this one would be consistent and dependent. Consistent and dependent. Because it's the same exact line. It's just hidden. So we need to make sure we pay attention to that. So we have consistent, independent, consistent, dependent, and inconsistent. Another example. Let's do this one by graphing again. Nice. The first equation is nice because we have the slope and the y-intercept. So we have y-intercept at negative 4. We have slope being negative 3 over 4, so we can go down by 3. And then we can run by 4. We can go down by 3, run by 4. Or we can go up by 3, run by negative 4. And so on. Okay, so let's go ahead and just connect those dots. Connect this dot. We're going to create our graph. For the other one, with this one, what I'm going to do, I'm going to go ahead and just solve it for y, get it into our slope-intersect form, and see what we end up with. So we are going to end up, actually, I'm going to do this one a different way. We're going to plug in some points. I want to plug in an x and a y. That way you can see a little bit variety of different ways of doing it. So if we have x be 0, this means that this is 3 times 0. Then we go plus 4y equals to 4. So this is 0 equals to 4y. Sorry, 0 plus 4y equals to 4. So in other words, y in this case is equal to 1. So 0, we are at 1. Now we have to figure out another point. Let's choose to do, let's choose 4. So if we choose 4, this would be 3 times 4 plus 4 times y equals to 4. So this would be 12 plus 4y equals to 4. Minus by 12. So 4y equals to negative 8. Then divide by 4. So y, make sure we get the right color, y equals to negative 2. So at 4, we are at negative 2. Okay, so let's go ahead and just graph that. Oh, that is the wrong spot. Let's go ahead and make sure it's going to be a straight line. There we go. No solution. These are parallel lines. If we would have solved out for y, we would have been able to see that these are the same exact slopes. So if you wanted to do the same method like we did in the last problem where we solve out for the y, you will notice that they will both have the slope of negative 3 over 4. So this one is inconsistent. And that is how you graph. So now let's talk about another method. Let's talk about a substitution method. We have the graphing method, so let's talk about substitution. We're not going to finish the substitution method in this video. We're going to continue that on into another video, but we are going to at least start talking about it. Here in this example, we have a bakery sells 2 types of pies. An apple pie sells for $15 and a cherry pie sells for $20. Last week, the bakery made $305 for selling 18 pies in total. How many apple pies did they sell? Solve this by using substitution method. Okay, substitution method, we are going to take one of the equations, solve out for x or y, and put it in place of that variable. So let's go ahead and just do a few things with this. First thing that we know is let's deal with the money. We know that an apple pie sells for $15. And we're going to say our variable is going to be a for apple pie, might as well. So $15 times however many apple pies we have. The other thing that we have is that cherry pies sell for $20. So $20 times however many cherry pies. So we're going to use C for cherry pies. We know the total cost of the pies was $305. So if we add the how many apple pies sold and how many cherry pies sold, those prices, we should end up with the price that we got in total for that week, or the weekend, for that weekend. The other thing that we have is we know exactly how many pies sold. We just don't know what type of pie sold. So if we have the apple pie and the cherry pie added together, we know that that's going to end up to be 18 pies in total. So we just created, based off of this word problem, a system of equations. We have 2 different equations that we are comparing, that we are trying to make sure have a common solution. So what we are going to do, we are going to end up doing a system of equations. We're going to solve this by substitution. How we use substitution is we are going to take one of the equations and solve out for one of the missing variables. So let's take the bottom equation. Let's take this a plus c equals to 18. It doesn't matter which one you solve for because both of them have a 1 in front. If either of these did not have a 1, we could still do it, but it's easier if you solve out for one of the variables that already has a coefficient of 1. So let's solve for a. If we solve for a, this would be a equals to 18 minus c. Okay, so we now know that the apple pie is equal to the 18 pies minus by however many cherry pies we had. Take this is the same a that is in the other equation. So let's take that equation and plug it in. We're going to substitute it in place of. So what we have now is we are going to have 15 times a, but a is 18 minus by c, plus 20c equals to 305. Notice a is 18 minus c. So we substitute, we put it in place of the other. So what we are going to have to do is we are going to end up simplifying and solving for the value of c. So we have 15 times 18, and 15 times 18 is going to be 270, minus by 15c plus 20c equals to 305. Okay, well then let's go ahead and get some stuff together. Let's combine these two c's, so negative 15 plus 20, that's going to be 5c. And let's get the constant to be on the other side, so we minus by 270. So doing this, we are going to end up with 5c equals to 35. So taking this, I'm going to just bring it up here. So we have 5c equals to 35. Solve out for c, so we divide by 5. So c is equal to 7. That's how many cherry pies we sold. We sold 7 cherry pies. So now let's find how many apple pies we have. If we know we sold that many cherry pies, then to find the apple pies, we just take that amount, plug it into one of the equations. It does not matter which equation. But it's more simple if we plug it into the a plus c equals 18 because we won't have to do any divisions there. So we have a plus 7 equals 18. Solve out for a, so a is equal to 18 minus by 7. So apple pies, we had 11 of those. So our answer is we have 11 apple pies, 7 cherry pies that they sold in that weekend. You could have also graphed this and gotten the same result. But because they said, let's solve this using substitution method, that is why we did the substitution method. Both methods work. However, the disadvantage to the graphing method is if your graphs are not accurate. If you do not graph it 100% accurately, you can end up with the wrong result, end up in the wrong answer. So you have to be very, very careful with the graphing method. With substitution method, as long as your algebra is good, as long as you know how to substitute and add, subtract, you will always end up with the correct result. The last thing that we're going to do is this last example. We have another word problem. A movie theater sells 2 types of tickets. We have an adult ticket and a child ticket. At the downtown location, the manager reports that 4 adult tickets and 2 child tickets cost $40. At the uptown location, the manager reports that 2 adult tickets and 1 child ticket cost $25. Write and solve the system of equations for the price of each type of ticket. And we are going to solve this using our substitution method. So let's create 2 equations. We have adult tickets. We know how many adult tickets we have, but we don't know the price. So let's still go 4 times whatever the price is. Let's call that A for adult. Then we are also going to have 2 child tickets. So we have 2 times whatever the price of the child ticket is. So at this first location, if we add the values of the price together, we should end up with $40. At the second location, we're going to do the same thing. So we have 2 adult tickets and 1 child ticket. That's going to be $25. We have just created ourselves a system of equation where we are going to compare the 2 equations and see if they have a solution in common. We want to know, write and solve the system of equation for the price of each type of ticket. With substitution method, notice the second equation we have C, which has a 1 in front. If C has 1 in front, we're going to just solve out for that variable. And then we're going to substitute and put it in place in the other equation. So solving the bottom equation, we are going to end up subtracting by 2a. So we have C equals to 25 minus 2a. Right? Subtract 2a on both sides, we end up with C by itself. Because it has 1 in front, we don't have to do anything else. If it had a different number, we divide by whatever that number is, and then you have the constant by itself. So going from here, let's take this value. We have C is equal to 25 minus by 2a. Take that value, plug it into the other equation. So plugging into the other equation, we have 4a plus 2 times 25 minus by 2a equals to 40. Same thing like the last equation. We're going to go ahead and distribute. So we have 4a plus 50 minus by 4a equals to 40. Get the a's together. Wait, 4a minus 4a is 0. Subtract by 50 on both sides. Subtract by 50 on both sides. We end up with negative, 0 equals negative 10? That's not true. So because that is not true, because we got rid of our variables and we end up with a contradiction with them not being true, we can say that now this would be inconsistent. There is no solution where we can find how much each ticket would cost in this situation. Plus, the situation is kind of a ridiculous situation for comparing the two. It wouldn't make sense for them to have the same price at each movie theater.